This example is going to be looking, well, we're going to use the same strategy of factoring, but utilize it for different things. We're going to look at where the function's positive and where the function's negative. What that means is if you, let's do a little quick sketch here. Coordinate plane. All right. There you go. Okay. Let's say the parabola does this, right? It's considered positive when it's above the x-axis. It's considered negative when it's below. So what this is asking you to do is to figure out where the function is considered positive. So over what intervals is it positive? So what we really need to find is where does it cross the x-axis? And the intervals are going to be split into, well, for a parabola, you can have up to 3 different intervals where you're looking at what's happening, and it's based on the x-intercepts. Well, how do you find the x-intercepts? The same thing we've been doing all lesson, right? Which is just factor in and see where the zeros are. So let's see what they have to say. So the first thing you do is set it equals 0, factor it, and you get the 2 zeros. So for this one, they're saying that the x is equal to 3 or negative 1. So if this is our quick sketch here, let me change it into color. Let's say that's negative 1, and then that one's 3. All right, not to scale, but you get the idea. What they're suggesting is then to create a table, and you can check values. So pick a point, an x value that would fall into 3 regions. So you have everything to the left of negative 1, between negative 1 and 3, and then everything to the right of 3. So they chose negative 3 as an x value because that's going to be in this interval over here. When they substitute negative 3 in, you get 12. So that means it's positive. When you substitute, then they chose 1 because 1 is in between negative 1 and 3. When they substitute 1 into the function, they get negative 4, so it's negative. And then they chose 6 because that's a number that's greater than 3. And then when they substitute that, they got 21, which is positive. That's fine. You can do a table like that. I think it's honestly easier to look at it visually as well. So then here is the actual graph of what they did. And you can say that the graph is positive for all the x values that are less than negative 1. And it's not less than or equal to because at exactly negative 1 is the 0. So everything to the left of negative 1, then everything to the right of 3. Mm-hmm. So let's take a look at another example. So at this point, I would pause it, try it, and then check back for your answer. The answer is going to be the intervals, the interval or intervals where the function is negative. Okay. I know that this parabola opens up because it has no negative in front of the x squared. So if those are the zeros, then it opens up. It's got to look like that. So where it's negative is going to be everywhere between negative 3 and 7. So the compound inequality that would represent that is negative 3 is less than x is less than 7. You could also say x is greater than negative 3 and x is less than 7, but I'm just going to write it as a compound inequality that way. So that's it. Let me know if you have any other questions. You could also do the test point thing that they were showing in the notes, but to me, I think it's easier just to look at it. If there was a negative in front there, then the parabola would have been upside down, and you would just draw it that way.